Hello, PascoMath. Today we're going to do some learning around 6.NS.1.1, which is a major standard in 6th grade, Unit A. The standard says, interpret and compute quotients of fractions and solve word problems involving division of fractions by fractions using visual fraction models and equations to represent the problem. So when we unpack the meaning of the standard, there's really an emphasis on fraction models. We probably want to start concretely with manipulatives, then move to visual drawings, and then finally equations. Students are expected to interpret, represent, and solve the word problems that involve division of fractions by fractions. And students are also expected to interpret the meaning of fractions, meaning of multiplication and division, and the relationship between multiplication and division to understand, be able to explain why procedures for dividing fractions make sense. Again, we really want to emphasize the concepts before leading students to the procedure. So now we're going to focus a little bit on what the teacher does to instruct this standard. As mentioned before, we really want to start concretely using hand-on models such as pattern blocks. So as you can see in the bottom right here, we have some of the typical pattern blocks. We have the yellow hexagon that we normally represent as the whole. We have a red trapezoid, that's half. We have a blue rhombus there, that's the third. And then the green triangle, that's the sixth. So these are typically a good setup for using pattern blocks in the classroom. And so one thing we might ask students to do is something as simple as we would ask them to just become familiar with these tiles. Maybe ask them to model a half divided by 1/6. And so if we ask them to do a half divided by 6, we would want them to start with the half, which is the red trapezoid. And then from there, there's a couple ways students could go about this. Because the meaning of division is how many 1/6 pieces fit in a half. And so some students might layer the 1/6 piece, if you remember, is the green triangle. And so they might layer it on top. And so see how many fit. And if they do that, they will see that there are 3 1/6 size pieces that fit into a half. So the answer of 1/2 divided by 6, how many 6 are in a half? The answer is 3. Some students might want to just recreate the figure on the side. That's appropriate too and okay. And so it just depends on where your students are at or how they want to represent it visually. So that's one way you can use pattern blocks to help students concretely understand division of fractions by fractions. Once they are comfortable with like simple unit fractions, things like this, again, just leveraging like how to use the pattern blocks. You might want to move into some more complicated cases. A more complicated case would be maybe asking them something like 2.5 divided by a third. So we're going to see how many 1/3 size pieces are in 2.5. And so for there, we need to model it first. So we want to model what we're starting with, which is 2.5. Again, if you remember, the yellow hexagons were the whole, so that's 1, that's 2. And I need a half, which could be represented by the trapezoid. So that's my 2.5. And I want to see how many 1/3 size pieces fit in. So again, the third is the blue rhombus. And so students could stack on top or recreate underneath. I'm just going to stack on top for space sake here with the dot cam. And so right now I see that it takes 3 1/3 pieces to complete one whole. Some students might just say there's another 3 here and not have to recreate it. Some students want to actually fill in all the space, so either way is appropriate, depending on where your students are at mathematically. And then this last piece, so I know right now for 2 holes, I took 6/3 to fill it up. But on this last piece, 1 fits, but if I try one more, it overlaps, there's not enough space. And so we can visually see it's a triangle, so some students might actually explore and see that the triangle actually fits there. And this is where it's really nice for them to interpret the piece of the standard, because now we have to determine like, what is this piece? What does this mean mathematically? Some students might have a misconception and call it what it is. They'll call it a sixth. So they'll say 1, 2, 3, 4, 5, 6, 7. So they'll say 7 and 1/6 is the answer. which is mathematically incorrect. And so because of the misinterpretation of the remainder. This remainder is half of the third here. And so the actual answer is 7.5 because of what's left. When we're saying how many 1/3 size pieces fit in to 2.5, we have 3, 6, 7, and then only half of a blue rhombus would fit there. So 7.5 would be the answer to that part, modeling it with pattern blocks. Then once we concretely understand and use manipulatives, maybe we can get students move into maybe a more pictorial state, and that's where we want them to maybe draw some pictures. So they continue with additional visual drawings to help students understand quotients of fractions by building from familiar scenarios. So just an example, let's say 3 people share equally half of a cake. How many pieces does each person get? And so we could ask students to draw a diagram to show each person gets a sixth of the cake. And so again, if we would want them to model this out, so I'm going to do a rectangle cake because I am not the best artist. And so right there I would have, my half of the cake. And then from there, I was saying, okay, so now I have half of the cake and I want to share it with 3 people equally. Well, if this is all I have and I want to share it with 3 people equally, I'll redraw it down here. So I need to split this up for 3 people. Pretend those are equal. And so then that's how much each person gets, but like how much of the whole is that? And so we want students to explore and figure out that that is 1/6 size pieces is what they would have there. So again, this is just getting them to explore a little bit of visually using pictorial models. We can also ask students to make sense of equations using a tool such as a number line. So we can have something as simple as, let's say that we are asking students maybe 2/3 divided by 6. And we wanted them to use the number line to represent that. So we could model this on the number line. I'm going to use 1 as my whole. Try to break it into thirds. Not the best at this, but pretend those are thirds. So I have 1/3, 2/3. And from there, it's like how many 1/6 pieces fit? Well, I know a 6 is a half of a third, and so now I need to break this up a little bit more. So there's 1/6, there's 1/3, which could also be represented as 2/6. Here we would have a half or 3/6 if we were keeping up the 6. Here would be 2/3 or equivalently 4/6. And I'm trying to figure out like how many 1/6 size pieces are in 2/3. Well, there's 1 piece, there's 2 pieces, there's 3 pieces, there's 4 pieces. So visually, using a number line, I can say 2/3 divided by 1/6 is 4. There's 4 1/6 size pieces in 2/3. It's really important to not skip this step when instructing students because they need to be able to conceptually understand what's going on. If we just go straight to the algorithm, which is appropriate at the end of the learning trajectory here, students won't understand why it works and whatnot. And so this, again, leads students from using manipulatives, diagrams, to computing the answer procedurally. So we do want to get there. Another nice thing to maybe ask students is just ask them, in the equation, a half divided by 6, why does a 3 make sense as the answer when it's so much bigger than a half or a 6? Really getting them to make sense of the mathematics. Now that we know what the teacher does, I want to move into knowing a little bit more about what the students should be doing. And the first thing is they should be modeling the division of fractions with manipulatives, visual diagrams, and word problems. They definitely should be hands-on with this, really engaging in the math, which leads me to the standards for mathematical practice. We really should emphasize using appropriate tools strategically, number 5, and also model with mathematics, number 4. Try to use as many problems that have context. That definitely helps students make sense of the mathematics. Also, dividing fractions procedurally, using the multiplicative inverse. Interpret what the quotient represents, like at the end there with the 2.5 divided by a third, we really were trying to make sense of what does 7.5 mean when we were dividing a fraction by a fraction. And then understand that multiplication, division, or inverse operations. This is huge for taking what they already have learned in elementary school and then also paying it forward because these inverse operations, multiplication, division, are really crucial for their work in expressions, equations coming up when we start to solve one-step equations in 6th grade. The other piece is student misconceptions, and so we know they will have some, and so like how do we best leverage them for learning in the classroom and use them as learning opportunities. And so the first thing they might do is incorrectly model division of fractions by fractions, um, and that's something that they'll definitely need address or practice with. Students may think dividing by a half is the same thing as dividing something in half, and these are definitely two different things. And so dividing by a half means to find out how many 1/2s there are in a quantity, but dividing in half means to just take that quantity and split it into two equal parts. So to address those misconceptions, I would have students just demonstrate two examples. Maybe have them model one that shows dividing something by a half, and another that shows dividing something in half, and then have them explain to you what's going on in those two different cases. I think if they saw both of those at the same time, it would really help them make sense of the mathematics and help correct any misconceptions that they have during that time. So I wanted to thank you for watching this video on 6.NS.1.1. I hope you have gained some things for your classroom and for when you design lessons for your students. If you have any questions, feel free to contact me or your regional specialist. And thank you for making PascoMath more awesome.